Hello everyone, welcome to your physics classroom. I am Lawal Adetunji, your physics tutor. To our returning viewers, welcome back to your classroom. To our new viewers, please do well to press the subscribe button on our YouTube channel. On our TikTok and Facebook, please press the follow button. Press a like and share our link with your friends. Put your comments in the comment box. As you have all known that in our classroom, we do it together. By now you bring out your book as we start the class. Once again, I greet all of us. Welcome back to the new academic section, and likewise welcome to the first term of the new academic section. As you have all know that in physics for grade 10, the week 1 is talking about the introduction to physics. After the introduction to physics, the next topic will be the physical quantities. And here we are with the topic physical quantities, and the subtopic here we have fundamental and derived quantities. The next question will now be, what are fundamental quantities, or what's the meaning of fundamental? When you hear the word fundamental, what comes to your mind? Fundamental means basic, foundation, independent, a particular quantity that has no producer, is just existing. So when we talk about fundamental quantities, in a simple statement, we say fundamental quantities are the quantities that cannot be derived from other quantities. That's one definition. You can also say fundamental quantities are the quantities that are not produced from other quantities. That's another statement. You can still say fundamental quantities are the quantities that cannot be what? That cannot be obtained from other quantities. They cannot be obtained, they cannot be derived, they cannot be produced from other quantities. Another one we cannot say, fundamental quantities are independent quantities because they do not depend on any quantity, but other quantities depend on them. Now let's write. Bring up your book and let's write. We say fundamental quantities are the quantities that cannot be derived. If you like, you can use produced or obtained, anyway you can call it, that cannot be derived from other quantities. They cannot be derived from other quantities. In the short run, we can say they are what? They are independent quantities. They are independent quantities. Independent physical quantities. Now that you have known the definition of the fundamental quantities, the next thing will now be, what are the examples of fundamental quantities? We have the following examples are the examples of fundamental quantities. I'm very glad to tell you that, do you know that your length is a fundamental quantity? When I say length in physics, whenever you hear the word length, length is a big word in physics. When I say a big word, it contains its family. What are the families of length in physics? When we say length in physics, our length can be distance, our length can be displacement, our length can be height, can be depth. It can be breadth, it can be width, it can be size. Whatever is measured in meter, they are the family of length, and they are all examples of fundamental quantities. So, example of fundamental quantities, I've mentioned length. Another example, we have mass. Mass is a fundamental quantity. Another one is our time. Time is a fundamental quantity. What about temperature? Temperature is a fundamental quantity. Electric current is a fundamental quantity. So let's try that. We have examples. Examples of fundamental quantities. Examples of fundamental quantities. I talk about lengths. The unit of length is meters. The unit, meters, that is the SI unit. Then anytime you write you are solving a problem in physics, you must put your units, except it has no units. we have mass. Mass is kg, kilogram. We have time, which is measured in seconds. We have temperature. Temperature is measured in degrees Celsius or Kelvin. Anyone you pick, you are right, depending. We can degrees Celsius or you pick Kelvin. In advance, when you are doing your when we get to the advanced class, maybe year 11 or grade 11, where we are talking about gas law, we will talk about temperature very well, and likewise how it can be converted from degrees Celsius to Kelvin by the addition of 273. All right, I move to number 5 example. I mentioned electric currents. Just to mention few, I have mentioned 5. Just to mention few, I'll be expecting you to drop more of the examples of fundamental quantities that you know inside the comment box. I want us to do it together to be interactive class. I have mentioned 5. Any other one that you know, put it inside the comment box. So this one settles the issue of fundamental quantities. Now let's talk about the derived quantity. From that statement, derived, we derive it, we produce it, we obtain it. I'm very glad to tell you that all the formulas in the world, they are all derived quantities. As we have thousands of formulas in the world, definitely it shows that all of them, they are examples of derived quantities. So when we talk about derived quantities, we can say they are unlimited. So when you take derived quantities are the quantities that are produced from other quantities. Or you say for the derived quantities are the quantities that are produced or that are obtained from fundamental quantities. That's all. If you want to speak the statement of is it independent? No, it is what for the derived quantities are dependent quantities because they depend on fundamental. Fundamental gave birth to them. So the derived quantities are dependent quantities. They are dependent. They are dependent quantities. Now let's talk about that one. Let me rub up my board. All right. For derived, as we have said, we said derived quantities are the quantities that can be what? That can be obtained from other quantities. If you like, call it from fundamental quantities, you are still correct. From other quantities. From other quantities. In that situation, they are what? They are dependent. They are dependent quantities. They are dependent quantities. Now that we have established the definition, the next thing will now be what are the examples. Like I told us, they are unlimited. But just to mention few, in this classroom we mentioned few, and I'll be expecting more from you as well in the comment box, especially when it comes out in our class entertainment. Now let's go. Examples of derived quantity. Examples of derived quantities. Examples of derived quantities. We have many, but let me start. Area. Picking area, when we talk about area generally, area is measured in meter square or a centimeter square in mathematics. But here, let's say I want to just say area of rectangle to bring that formula. Area of circle pi r square. Now area of square L square, but here I want to talk about area of rectangle. All of them, they have the same unit, they have the same dimension. But what I want to speak of, I want to use area of rectangle as an example here. Area of rectangle, that is length times breadth. Remember, I've told us that when you talk about length, it is a big word, it's a big family. Length can be breadth in physics, can be distance, can be displacement. So that is they are all measured in meters. Now, area of rectangle, length times breadth. The unit of length, meter. The unit of breadth, meter. So finally the unit is meter square. That's how we got that unit, meter square. Because of our time, I move to the second one. Let's say I pick volume now. Let me pick volume. I pick volume. We can also have volume of cylinder, volume of cone, and so on. But let me say I'm picking volume of cuboid. Volume of cuboid. Cuboid, length, breadth, height. So we have length times breadth times what? Times height. Remember, all of them, they are all measured in meter. Meter times meter times meter. It will give us what? Meter cube. Now, let me now go to the basic physics terms. Now, let me start with the first one. I have speed. When you talk about speed, you are talking about the distance covered per unit time. That is, speed is distance over what? Distance over time. Remember, I've told us that length can be distance. It can be height. It can be displacement. So, don't miss it. I'm still talking about length over time. Distance over time. So, the unit will be meter over seconds. That is meter per seconds, or you write it in form of indices. ms raised to power minus 1. Alright, moving forward, I pick number 4. Remember, I told you said they are unlimited. I will just mention few in this video. I also give you as a task in the class that meant to give me more. And likewise, we continue in the next video. Now, speed, I pick now, let's say I pick velocity. I pick velocity. Velocity is displacement covered per unit time. So, displacement over time. Displacement over time. You see the family of lengths? So, we have the same unit, meter per seconds. Now, moving forward, I go to acceleration. When you talk about acceleration, acceleration is a change in velocity per unit time, or you say it's the rate of change in velocity. We are saying the same thing. So that is what we want to achieve, is that velocity, change in velocity, velocity over what? Over time. Velocity over time, and unit of velocity is what? Meter per seconds. Meter per seconds over time. Meter per seconds over seconds. That one will give us what? Meter per seconds square. So we settled 5 here. Let's see if I can still give more in this video before we enter the class entertainment. Let me give us 3 or 4 more before we enter the class entertainment. Okay, let me give us like 3 or 4 more before we enter the class entertainment. Now, I want to move with speed. Let's say I move to what we call force. When we talk about force, that's the product of mass and acceleration. And force, we have force in various forms. Don't worry, step by step we'll know it. Please do well to watch our video on force, and likewise the Newton's law of motion. You'll be able to know what we talk about force. Okay, we said force is the product of mass and acceleration. That is, force is mass times acceleration. Mass times acceleration, that is F is equals to ma, and the unit is Newton. The unit is Newton. That's the unit. If you want to break the unit down, it can also be kilogram meter per second square. Alright, let me see if I can still measure more. I mentioned Waec. Waec is the force applied through a distance. So what are we saying? Waec is equals to force times distance. Force times distance. In case the pace may be too fast, or in case the teaching may be too fast for you, just calm down, watch the video again, and you flow with it. Watch it at your own pace. Okay, and put your answers or comments in the comment box. Alright, we say Waec is equals to force times distance. In that situation, we can also bring the unit from there. Force, the unit of force is Newton, the unit of distance is meter. We can say Newton meter or joules. The main unit or the standard unit of Waec is joules. That is, we have joules, which is J, or you say Newton meter. We are saying the same thing. I want to move with speed right now. I say I pick up power. Power is the rate at which work is done. Definitely work over time, which means joules per seconds. Let's see if I can give one more with my space here. Okay, I picked one. Let me pick momentum. I pick momentum. Momentum is the what? Is the product of mass and velocity. That is mass times velocity. If you can check very well, what we are doing here is just merging parameters together. We are merging parameters. Remember when I was defining, I said derived quantities are the quantities that are produced from other quantities. I said other quantities. That is, the other quantities can be derived, it can also be fundamental. If you check this place now, this is fundamental. There are some places where I use derived and fundamental. This is a derived, this is a derived and fundamental. So telling you that what the definition that covers it all is one that said they are derived from other quantities. Are we there now? So I have mentioned this now. I just mentioned 9 out of like 100,000s, or let me say thousands, of the formula or the derived quantities that we have. Alright, because of our time, I don't want the video to be too long. Now, let's go to the class entertainment. Yes, welcome back. Here we have our questions for the class entertainment for this video. The first question said, state 3 differences between fundamental quantities and derived quantities. While the second question said, mention 10 derived quantities apart from those 9 mentioned during the classroom. I repeat, state 3 differences between fundamental quantities and derived quantities. And secondly, mention 10 derived quantities apart from those 9 mentioned in the classroom. Please do well to share our link with your friends to enjoy this class together like this as we are doing. On our TikTok and Facebook, press your follow button, like and share. On our YouTube channel, please subscribe. Press your like button, share, and put your comment in the comment box. I'll be waiting for your answers in the comment box. Now see you in the next video. Bye.